Unit 7, question number 7. Question number 7 wants us to divide a polynomial by something called a monomial. Alright? The word poly means many. The word mono means one. So we're going to divide many nomials by one nomial. Alright? So when you're doing this, guys, I'm going to make it very, very easy for you. So this right here is technically the denominator. Alright? These are the numerators that all have this as a common denominator. So I could rewrite these as fractions, where it's 16y to the 4th power, so this numerator, over this denominator of 4y to the 2nd power, or 4y squared. Alright? And then rewrite the other ones the same way. Plus 24y to the 3rd power over 4y squared. And then minus 28y to the 2nd power over 4y squared. Because again, each of these have this as a denominator. Okay? So I just rewrote these with this as a denominator. Now I'm going to go ahead and divide. Now I'm going to do what, guys? Divide. So if I divide 16 by 4, I get 4. Okay? When you're dividing things that have the same base, so they have that same variable y, you subtract the exponents. So what's 4 minus 2? Yup, 2. So we have y to the 2nd power. And this is simplified. Now let's do it right here. 24 divided by 4 is 6. Okay? When you divide things that have the same base, you subtract exponents. So 3 minus 2 is 1. Alright? And that's simplified. Now I'm going to divide here. Negative 28 divided by a positive 4. A negative divided by a positive is a negative. 28 divided by 4 is 7. So a negative 7. Y squared divided by y squared. 2. So again, when you divide things that have the same base, you subtract the exponents. 2 minus 2 is 0, or they cancel each other out. Okay? So I just have negative 7. Alright? And this is the answer. Alright? So let's try the next one. So again, guys, each of these have a common denominator, which is 2z. So I am going to rewrite this as 6z to the 3rd power over 2z plus 6z to the 2nd power over 2z plus 14z over 2z. And now let's divide, okay? 6 divided by 2 is 3. Whenever we don't see an exponent, all right, you always assume that exponent is a 1, all right? So 3 minus 1 is 2. Because again, when you divide things that have the same base, they have the same z, we subtract the exponents. 3 minus 1 is 2. 6 divided by, so again, this is simplified. Now I'm going to simplify here. Positive 6 divided by positive 2 is positive 3. When we divide things that have the same base, you subtract exponents. 2 minus 1 is 1. Or you can leave it as just z. Okay? Now let's simplify this one. 14 divided by 2 is positive 7. So again, this z does not have an exponent, but you always assume that exponent is a 1 when you don't see an exponent. Because we're dividing z by z, both of these cancel each other out. Because 1 minus 1 is 0. So again, both of these cancel each other out, and we're left with, sorry, this should be a 7. So again, this is a 7. Sorry about that. My handwriting messed up. Alright? And that is my answer. Alright? So let's go ahead. Let's do the last one. So again, we're going to write 20t to the 4th power over what, guys? Over negative 4t to the 2nd power. and then minus 12t to the third power over what, guys? Negative 4t to the second power. So now let's go ahead, let's divide. All right, 20 divided by negative 4 is negative 5. When I divide these two, I subtract the exponents. 4 minus 2 leaves me with 2. All right, so now we're going to go ahead. So this is already simplified. Now we're going to do the same thing here. Negative 12 divided by negative 4, and negative divided by negative gives me a positive 3, because 12 divided by 4 is 3. So again, we're dividing the exponents, or dividing these terms. So when you divide, you subtract the exponents. 3 minus 2 is 1. Or you can leave it as just t. So again, this is the answer. Alright? So again, guys, pretty easy, pretty straightforward. Alright? So good luck, guys. Good luck.